let's go talk about structured outputs today. Many of you are probably using it. And when I think about structured outputs, I think I probably think of them very differently. What I want to think about are type systems, because I personally find type systems one of the most powerful ways to go describe the world for almost every piece of software. But what does that really mean? Let's start with a really simple example. Let's say I have an LLM that really needs to understand this visa form from the Kingdom of Cambodia. Now, one thing is I can obviously put this in the ChatGPT and have it go understand this. But another thing that I could go do is, what if I could go ahead and ask a model to go understand what this thing is representing? And as it does it, once it produces the result, it could turn this into some sort of structured schema almost dynamically and in real time. And then against that schema, go and extract all the data out of this. The thing that ends up happening is you end up with a really beautiful outcome here, which is in real time, the model is suddenly able to go take this form and turn it into something that is incredibly useful. From a thing that was either paper typed, faxed, scanned, hand signed, it doesn't matter. It can turn into strictly structured data. And what you can do with this structured data is you can put this into a database. You can process millions of visa forms and guarantee that each one of them comes back in the exact same schema. And even this thing, it's very possible that I recorded this in real time. So let's try something even more dynamic. Right over here, I've got my phone, and I'm going to go run this and just see what happens when I run the same system. The whole goal here is, what I really want to be able to do is I want the model to go from something that is totally unreliable to something that is reliable, something that I can suddenly trust and make it actually behave in a good way. And how do we do this? Because up until now, we have lived in a world where if software fails, and I don't mean AI code, but if software fails 5% of the time, we shut down those companies completely. They're not allowed to fail 5% of the time. But I'm going to change one really quick word to LLM, and some of us might feel differently. And I think my thesis on this is that's not okay. We shouldn't feel differently. We shouldn't accept 5% failure rates just because we're happening to use LLMs. And while we're going down this journey, the thing that I think is really important is, why does this actually happen? The reason that this ends up happening is because as a developer, something has fundamentally changed. In the past world, when software went down 5% of the time, the cloud providers or the database providers could actually go fix this on our behalf. But now, all of a sudden, the burden of reliability is actually in your application code. There's nothing that the cloud people can do to make it so that your app has better error tolerance. And we've actually, my background doesn't really matter. I think what matters more is, like, we've done this before. We've done this before in the form of websites. Many of you, or some of you at least, may have actually seen websites that used to look like this. Some of you might have feelings about website code that looks like this. And in this world, what ends up happening instead is we've decided to delete all this code, and we now write websites like this. For those of you that don't know this is React. This is a front-end library that allows you to represent HTML code instead of as massive strings in a more structured format. And this has a couple key benefits when you frame the world in this way. But the main benefit is we get really, really good errors. Additionally, if you forget the slash, instead of it breaking when you deploy the website, the breakage happens at compile time before you deploy the website. Whereas over here, if you forgot the slash, the breakage would happen. You would just ship the code, and eventually your website would just render incorrectly. On the other hand, if you wanted to make this button re-render when the count changed, that's just a very hard thing to do without having something like React, which automatically handles that for you. And the fact of the matter is, when you look at agentic code today, most of you probably have written code that looks something like this. And my personal opinion is that this is horribly ugly. The demo I showed at the very top, where I asked it to do a very quick thing where it says, no matter what the data is, describe a schema that describes to me what I'm getting, and then be able to write the prompt in some way, is some blend of English with schemas. It's not this giant blob of just English. And similar, if you go look at React code, websites used to be just English until we decided to add some compose, some structure on top of it. And that allowed us, they gave us the right to build incredibly complicated and sophisticated websites along the way. So Why does this actually matter? Well, the problems that we have are very, very similar. We have strings, which is true, but there's other problems that are actually way more related than I think other people give it credit for, which is if you actually want to go ahead and change one thing in your system, in the past, if you had to change one web component, you never knew what other web component would break. In React, you get errors. On the other hand, if you change this model, you have no idea what will break. If you remove this /n, it's virtually impossible to know that, oh, this might actually read as a minus sign instead of bullet points because it's on the same line now. And composing that understandability is actually quite challenging when you're smashing a bunch of strings together. But I think the most important part here is actually the fact that your iteration loop ends up taking incredibly long. In the old world of web development, whenever you wrote websites, what ended up happening was you'd ship your website, you'd have to re-navigate to instant pages. On the other hand, in the new world, if you change one component, React ensures that only that one component re-renders during your developer loop. It's why we can iterate and come to a conclusion on a really good website really, really fast. On the other hand, in prompting, it's very similar. If you change this string, you have no idea what other downstream code is going to be impacted by it because this is just a string. It's not structured in any meaningful way, and the language has no semantics of helping you. The burden relies purely on you as an application developer. There's no tools that are making life slightly easier. So if we were to reinvent and think about this in a totally different way, in a first principles approach, what might happen here? Well, before I show you that, I want to give you a different perspective on how agents can be perceived. And I think we've all looked at LLM stuff. And one of the things I personally find incredibly confusing about this is the amount of new jargon and terminology that's being introduced almost every single day. While we go do that, let's think about how we can model an LLM call. I want you to think about an LLM call as just a function. Ignore how you implement it completely, ignore that, and just think about it as a function signature. A classification system is a thing that takes in some message and tells you that it's one of three things. How it doesn't really matter, but if I can be guaranteed that as long as I give this thing a message of some kind, it will always return positive, negative, or neutral. Well, most engineers in any language kind of know how to deal with these. You just call the function, you give it a message, and you're guaranteed that category will be one of these. And you can do this in Python, TypeScript, async system, almost any system out there. And whenever these fail to give you one of these three categories, we also know how to do that. We just handle exceptions. We've done this for APIs design almost everywhere without ever having to redesign it. But then we have a concept called tool calling. Well, I think we can model tool calling. Let's try to model tool calling in a very similar way. In this case, tool calling will say, given a message, I want you to pick one of three tools. Well, the tools are really just schemas that are filled out based on what the message says. So if the user says, what's the weather in San Francisco, it should call the get weather tool with the action get weather, and the city should be San Francisco. It may or may not fill out the zip. If it says, hey, remind me to go call my mom tomorrow, it should say, notes should be call my mom, and the date should be, maybe it's tomorrow, if it has the date context, or I have to model a relative date in some interesting way. And if it just says reply back to the user, I can just reply back to the user with a specific message. But we can now use this in our regular code in a really easy way, which is we have a function that takes in a message and returns one of three types. This thing will be either get weather, add reminder, or reply. And we write an if statement around it, where we call the appropriate function in each specific scenario. So we don't really have to invent a new concept. We can actually just use existing concepts to model tool calling, which is just a union plus an if statement or a switch statement. Now, what about parallel tool calling? I think this is where this starts to make it a lot easier to comprehend. Now, instead of actually having to model it as a special thing where we need new words, again, where we have tool calling and the parallel tool calling, we can just say that this is a function that instead of returning a union, it returns an array of unions. And now in your actual tool implementation, instead of just getting the tool, you also just add a for loop on here around the same switch statement that you have. And now your life has become a lot easier. We've leveraged the same thing from before without inventing anything new, and we still have this working just like before. And if you did want to actually execute all of them in parallel, instead of running these in an if statement, you would write async IO and run them all in parallel. So the idea here is we can use type systems to really do a good job of helping us grok what is actually happening under the hood. Now, then we get to this thing at a little haywire, which is agents. How the heck do we model agents in this world? I think most of us have probably written a game like tic-tac-toe or played a game like tic-tac-toe, and we can understand how that game works. We run the game forever until the game either ends due to a tie or it has ended because of or someone has won. So every turn, we check whose turn it is. We ask that player to take a turn. We check the end game state, and we keep on going. I think most agents can be modeled in the exact same way. Let's try and do that. So I have a thing that's going to determine what's the next action to take. This is going to take a state, which represents the current view of the world or the chat history, and it's going to return a union of tools along the way. And what we'll do now is we'll start our agent. The agent will have some initial condition. We'll run a while loop. We'll ask the model to go give us the next action. We'll run the same switch statement that we were running before for tool calling. But now, instead of some of these conditions will exit out of the condition of the actual whole function. Some of these will just mutate the state in some interesting way and add the next context. And we've suddenly built an agent. And while there are a lot of frameworks to help you go do this, I personally have found it to be extremely powerful to just use the primitives, because when I think of it this way, I get full control. I can choose exactly how many times I run the get weather tool. If I run the get weather tool 5 times, I should exit the loop. If I've added 15 reminders, I should exit the loop no matter what the model says, because I've decided that it's too many reminders to tell the user. If I've spent too much money and I want to go exit the loop, I should be able to do that. If it's been running for 15 minutes, I should be able to go do that. If the user sends me an interrupting message, I should be able to do that. But the beautiful thing about using existing paradigms to model this without having to invent anything new is we can leverage the last 25, 30 years of software development practices and use them all here. Everything we've learned in distributed systems and database technology can still come into play here without having to do everything from scratch all over again. And then we get to another word called subagents. Well, subagents are really just also functions. If the get weather tool, for whatever reason, was using another while loop with its own state context, well, there you have it. You have a subagent. Well, we haven't really had to model this in any interesting way because we have a thing that composes and builds on itself really well, which is just general functions. The fact that get weather uses an LLM and has a while loop and an array inside of itself doesn't matter. All that matters is get weather is just a thing that the top level agent uses, and how it uses it is independently decided. So this is kind of the world where we have found where if we can model the world using existing technology, we can take advantage of all the testing systems, all the reliability pipelines, and everything on top of that to get to a really good place. So how does this work truly in the world of agents? Because there are a lot of frameworks and systems that let you go do that. And what are the real benefits of structured outputs when you really push them to a limit? And how can this system help us? Well, I'll try and give you a first glance perspective on how we model the world here. So we did something incredibly silly. We made a programming language. Why we made a programming language, we'll share in a little bit, and hopefully it'll become a little bit more obvious. But I'll just show you what it feels like and how we can leverage structured outputs to get extremely high quality results. So in this case, we have a function whose job it is to extract the resume. I'm going to take in a string. I'm going to spit out a resume type. The resume type we're going to start off is really, really simple. It's going to have a name, an email, which is optional, an experience, which is a list of strings, and then a bunch of skills. But unlike most functions, we're just going to describe this as what model are we going to use. We're going to describe this as what prompt are we going to get out, and then we're going to go ahead and write a test case. Now, when we go do this, I think the most important thing about AI development is it's actually really important to think about how you can do test-driven development, because AI is all probabilistic. Like we talked about, the burden of reliability ends up on you as a developer. So how are we going to make this easier, and how are developers going to get better results? Well, the first thing I think is really important is actually just reading the prompt. Right over here, you can say something like extract a resume, and you can see it pops up right away. So you can actually get a really good proxy of what is being sent to the model. So that's part one. But I think the most important part is actually this play button. When you actually hit play, the model spits this out and you get your result out, and this matches the schema, and life is wonderful. But what if I wanted to ignore all Gmail email addresses? Well, I have two different ways of doing that. One way is I can just tell the model, ignore gmail.com addresses. And now the prompt will say ignore gmail.com addresses. And there's two ways I could have done that. I could have written it in my general instructions, like rules, ignore gmail.com addresses. And this could be up here, or I could write it as a part of the schema. And when you do structured outputs, you get two different benefits here. Putting it up here initially seems much easier, but as you get 50 or 70 or 100 rules, this actually becomes harder and harder for the model to remember, because they're like, think about how far these tokens are. This token is just considerably further from the field that it refers to than these tokens are. The distance between these tokens is just larger. So if you want to make it easier for the model to understand, you should put more relevant information closer to itself. So that's tip number one for getting better outputs from structured outputs. So let's go do this and let's see what the model does. If the model does this, it gives me null. That's fantastic. And maybe I can trust the model and it will go work. Maybe for a smaller model, it may not work. So I might try prompting a few different things to go make it work. But there's another thing that I could have done. I can simply say something like @assert. What if I did something like this, where I'm just telling myself that gmail.com this is a string which is not allowed to have gmail.com in itself. So I haven't changed the prompt in any way. So in theory, the model should spit out the right email, but what you get out is actually a null. Well, that's because the thing the model gave you doesn't match the type system of what you were expecting. And that's kind of the goal. The goal is that you as a developer get a lot of choice in how you go do things. So for a thing that a model does extremely well, you can let the model do it. For a scenario where you need extremely high reliability, you can marry it with the beauty of regular code and bring the two together in a way that's extremely readable. Let's do a few more things. Let's say I'm going to change my data model. So now experiences is going to be a list of experiences. I've written that out over here. Sometimes I'm using English to add some more metadata, like in the case of start date. And for this test case, I'll go run this and see what happens. Give it a second. And as I go run this, you'll notice a few more things. Firstly, the model decided to speak backtick JSON. What's cool is you didn't have to think about it. You still got out the system you wanted. And we got the shape of the data we wanted. Now, this is getting to be pretty useful. But what if I wanted the name of the company and only get the legal name of the company? This is where I think structured outputs can be extremely powerful. So I'm going to tell the model, use the legal name of the company. And we'll see what happens, because we have boundary ML, which is an unknown entity. We have Google, and then we have Xbox, which technically belongs to Microsoft. So let's see how we could go solve this problem. So what did the model do? Boundary ML, Google, Xbox. It really didn't listen to me, and I don't know why. And I can try prompting this to make this work, or I can try something else. What I can do is I can just say class company, and I can say the company is a thing that has a name, it has a type, it's either startup or well-known, and then it has a separate field called legal name. And I can swap this out from the company type and just see what happens. So now experience is a list of companies which have these things and more metadata. Let's try running this. As we're going about it, the boundary ML is a startup, which makes sense. Probably Google is a well-known company, no legal name, and Xbox, well-known company, no legal name. Let's try adding some more metadata into this company. And I'll just leave this as an actual string, so there's no null as an optional thing. The name of the entity. Let's try this and see what happens. So it came up with a name for this. For Google, it did use the right name, Google LLC. And then for Xbox, it used Xbox Game Studios. It's not Xbox Game Studios, it's actually Microsoft Corporation. So let's try that. Or holding company. And let's try running this. And you'll notice what I'm doing here. I'm live editing the code. Sometimes I'm modifying the schema. Sometimes I'm modifying the English. And as I'm going to go edit this, you'll notice that the results come out in a more interesting way. Google LLC, and in this case, I got Microsoft Corp, which is probably much closer to the right information, but there's no guarantee that this could have been correct. So how do we get our results to be 100% correct in the world of AI? Because most systems, like we talked about, aren't okay with a 5% failure rate. In this case, we got the wrong name for the startup, we got the right name for Google, and the right name for Microsoft, hopefully. And if I run this 15 times, I hope it continues to be true. But we don't want hope. We want guarantees. So let's talk about how we can go do this from like a regular standpoint. So we're going to take this function and we're going to start building some Python code around it. So what are we going to do? Well, we're going to say a resume is equal to b.extract resume, and we're going to pass in some resume text into here. We'll load it from a string, pass from a function, doesn't really matter. Resume is guaranteed to be a resume type because your function returns a resume type. For experience and resume.experience, this thing is guaranteed to be experience type. If I change this to be a string array instead, then this thing is going to be a string. So you get extremely good type safety across the bridge in almost any system that you're using. What we can do with this type safety and using type systems is you can do something really elegant, which is we can say if I'm going to make this shorter so I can, if experience.company dot type equals, and this fills out. If it's a startup, I'm going to do something. I'm going to say that experience.company name is just an empty string. Oops, not legal name. Is always going to be an empty string. So no matter what the LLM says, if you're a startup, I'm just going to void it out completely along the way. And then what I'm going to do is I'm going to say, otherwise, for your legal name, I'll run a function that I have imported from somewhere. So I'll write a function called def validate company, which will take in a name, string, oops, I don't write Python very often, legal name, stir, and return a Boolean. And for now, I'll write pass over here so we can implement this later. And I'll fill this out. Now, what I can do over here is I can say, if not validate this, I can either raise an exception saying, hey, this is an invalid company name for my current. I can say that this company name is actually invalid along the way, or because this is not, the legal name is not found, or I can say, what I can do is I can say, ask an LLM what the right company name is. And I can make another model that says, ask a better company name, where I give it a company name, a company legal name, and ask it what's a better company name. Better name. And I can try again. It's like validate company, better name, and then go search for this. And how can validate company be implemented? If not this, I can try one more time, or I can just say, in this scenario, I don't really have a legal name, and I'll void this out. So what I've done here is I've kind of leveraged structured outputs in two different ways. In one way, what I've said is, in one system, what I've said is I can get a model to turn every problem into a structured output problem, whether it's tool calling, parallel tool calling, or a general data extraction problem, or a classification problem. Almost anything can be transformed and viewed as a function signature. And then I can make my data much more rich from the model by leveraging a combination of English combined with a combination of schemas. But then I can do a third thing, which is I can leverage code while I'm doing this to both not have to force the model to do everything, but really allow code to do what code does best. And the idea here is very similar to what Andrej Karpathy talked about when he said, we're in a world that uses like software 3.0. Well, not all software is software 3.0, and software 1.0 and if conditions are still probably going to be alive for a few years, at least, because models are just not very good at writing this kind of code. On the other, or executing this kind of code is what I should say. You're not going to write a for loop in a model because a model doesn't do math very well. You wouldn't multiply currencies inside of a model, but you would use a model to really extract really ambiguous information from really unstructured data or chat threads or images into something that the rest of your software can use. And when we decided to go think about FAML, one of the most important things that we wanted every single person in the world to be able to take advantage of it. So whether you're a Python developer, a TypeScript developer, a Java developer, C++ developer, The idea is that you should be able to use existing functions anywhere you want in a very type-safe way. So in this way, where experience changes to a string, not only does my Python code change, my TypeScript code changes. So if I'd done something that would break it in some way, this will yell at me and say, it doesn't exist on a type string. But if I change this back to experience, the error will go away because this thing is a string, this thing is an object. The idea is that type systems can really make your life as a developer a lot easier, and they can move some of the application burden that we introduced at the very beginning away from the application developer and into systems that can go do this. When we started this, we talked, one of the most important ideas that we had were F strings are just, they're not a bad way to write code, but they shouldn't be the only way to write code. And if you're a Go developer, if you're a C++ developer, if you're a Java developer, if you're a TypeScript developer, all of you should be able to use LLMs. And we want really engineering principles in them, not vibes coded into our system, because vibes are a liability. What we want are maintainable, reliable systems that we can depend on for years, like the majority of software many of us use. But we have to go update every line of code we had written ever in the past all the time. We wouldn't have software services. We wouldn't have software companies. BAML is completely open source. It's Apache 2. It's air-gapped. It works with any model of your choice, works with any language of your choice. We have thousands of companies that have now built on it. We have millions of dollars of revenue running through their pipelines that they depend on to go do this. And you can run it on any system of your choosing. We did make a programming language, so I know it's a totally wild thing that we went out there to go do. But our theory is the least we can do is make it easy for you to go learn it. So this is our Discord response rate, because sometimes if a language is broken, it is really, sometimes you just don't know what to do. So you can always go ask us, and someone either from our team or the community will respond extremely quickly to make sure that we're unblocking you. Now, if this was somewhat interesting and somewhat useful, this is our, you can sign up for more information here. But I think the most important part really is I want you all to think really hard about what could we do if we actually took models and we suddenly didn't make them 5% failure rates? And 5% failure rates are good, but what if we didn't have that? What if we had 9s of uptime and we could suddenly trust models as reliable piece of software? Because every single piece of AI that you've ever built is really a trust building exercise between you and the customer. Every interface that you build, every UI that you build, every time you get something wrong in your product, the customer loses a little bit of trust. So if it's hard for you to go build something, for example, like in this case, we all know that ChatGPT can go generate recipes. But what is really hard to do while ChatGPT generates recipes is make it interactive while we're generating the recipe. And if these kinds of things are hard, then we're going to live in the React world, where if you're writing code, you're just not being able to go ahead and go update things very easily. You'll make non-interactive websites. We don't want that.